Hello, in this video I'll show you a new way that we can represent complex numbers, which is called modulus-argument form. So I'll start off with a generic example to show you how it works, and then I'll do a couple of examples as well, and I'll timestamp each part of the video below. If this video is useful, then please do like and subscribe. So previously we looked at how to find both the modulus and argument of a given complex number. In this video we're going to extend on that and see how we can rewrite complex numbers in a new form called modulus-argument form. Now, the form we're used to seeing complex numbers in, like this, z equals a plus bi, is called the Cartesian form. Okay, so we're used to seeing complex numbers in a Cartesian form. So to see how we're going to find this modulus argument form, let me first sketch z on my Argand diagram, and I'm going to say it's this point here. So here's my complex number z. I'm going to have a vector going towards it like this. And so this point here is a, and this point here is b. Let's say we then calculate the modulus of this complex number. So I calculate the modulus of z and I find that it's some value r. Okay, so I could label that on. I then find the argument of z. So I've calculated the argument of z, and let's say that's equal to some angle theta. So let me also label that on. Let me now construct a right angle triangle. So I'm going to drop a line going down like this at a right angle. Okay, and we can use this to rewrite this form that we're used to, rewrite our Cartesian form. And the way I'm going to do that is by saying, well, this length here, the opposite side, okay, of this right angle triangle, well, that has a length of b, hopefully you can see that. And the adjacent side of this right angle triangle, this one here, has a length of a. So let me use sine and cos to rewrite this. So I'm going to say, okay, sine of theta, well, that's going to be equal to my opposite side over my hypotenuse, and cos of theta, which is my argument, is equal to a over r. Okay, hopefully you can see that. Let's now rearrange these to make both b and a the subject. So I'm going to multiply both of them by the modulus of our complex number, and I get r sine theta is equal to b, and for this one I'm going to get r cos theta is equal to a. Okay. Let's now substitute these values into our original Cartesian form. So where I have a, I'm going to be writing r cos theta, and where I have b, I'm going to be writing r sine theta. So let me write that just down here. So I've got z, our complex number, can be written as a, which is r cos theta, plus b, which is r sine theta, multiplied by I. Let's then factorize out the r, and we get r multiplied by cos theta plus, and it's usually written like this, I sine theta, okay, where r is equal to the modulus of z and theta is equal to the argument of z. And this here is what we call our modulus argument form of our complex number. So let's now look at an example to see how we can calculate this. So we have the following complex number z, which is 6 plus ai. So the first thing I'm going to do is find both the modulus and argument of this complex number. So I'm going to sketch out my Argand diagram like this. So that's my imaginary axis. This is my real axis. I'm just going to label them. So I've got 6 plus ai. So that's maybe going to be up here somewhere. So here's the complex number z. Well, let's first find its modulus. That's pretty easy. That's going to be equal to the square root of 6 squared plus 8 squared. Let me type that into my calculator and see what we get. So we get the square root of 6 squared plus 8 squared, which is 10. So that's the modulus. Let's now calculate the argument, which is this angle here. So the argument of z is that angle. And so that can be found by doing the inverse tan of 8 divided by 6. And we get the argument of z is equal to 0.927, say, to 3 decimal places. So let's put it into our modulus argument form. So I've got z is equal to 10 multiplied by cos 0.927 plus I multiplied by sine 0.927. And so that is another way of expressing that complex number z. Hopefully this video was useful. If it was, please do like and subscribe, and go over to my channel where I have loads of other maths tutorials. Thanks for watching.